This is the fifth video in a series of steamer updates. It's about how to put a steamer with a blown circuit board back into service. This is a burned out circuit board that was damaged when the heating element shorted out. It's not possible to repair the original circuit board to factory condition. It has a custom microcontroller that is not available on the open market, plus it is programmed with proprietary software. The steamer can still be put back into service by replacing the heating element plus a way to switch it on and off. You can use a plug-in countdown timer, so it isn't necessary for the replacement circuit to have timer functionality. A simple circuit with minimal on-off control is all that is required. You can also install a cord switch for on-off control if working with electronics is not feasible. The following slides show how to install a cord switch for those who don't want to work with electronics. Seal the metal dish as shown in a previous video. Then desolder the power cord from the circuit board and install the cord switch onto the live conductor. Then connect the ends of the power cord to the leads of the replacement heating element. Mount the circuit board into the unit as shown so that the wires are covered. Reassemble the unit as shown in previous videos. The next part of the video shows how to make a homemade circuit board with minimal on-off control. Some of the electronic components are the same type found in the original factory circuit. There are links in the description below for the printed circuit files and electronic parts. This is a schematic for the circuit. The portion of the circuit inside the dashed line is from another online source which was adapted to this steamer repair circuit. There are also links to videos that show step-by-step how to transfer the printed circuit artwork to a copper-coated board. You can even make a perf board version of the circuit if you prefer. A perf board layout is included in the document files. When making a printed circuit board or PCB or PC board, the conductive tracks and pads need to be transferred from the artwork to a copper-clad PC board. The copper surface is scrubbed clean with a stainless steel scouring pad first. The artwork is printed on glossy magazine paper using a laser printer. I'm using nail polish remover for this board, but you can also use a hot iron to transfer the toner to the copper surface. Apply pressure to the entire area that needs to be transferred. After a few minutes, the solution will evaporate and the paper will be dry. Carefully peel the paper off and inspect the result. Use an industrial felt tip marker with super permanent ink to cover areas that need to be touched up. The next step is to etch the printed circuit board. Ferric chloride is used for this purpose. Remove the board from the solution as soon as the etching is complete. Rinse the board in plain water when finished. Scrub the surface with a stainless steel scrubber to remove the toner. The next step is to trim and shape the etched PC board. I'll use a jigsaw to remove most of the material. Then I'll use a sanding block with 50 grit paper to remove the rest. I'll use a file to make the cutout in the board. Then I'll use the sanding block again to make a radius on each corner. Drilling the circuit board holes is done next. After drilling, the top surface is scrubbed clean. The next step is to transfer the component outlines to the top of the PC board. We'll need to transfer the toner to the board like before. Use even pressure to transfer the toner to the board. When the solution evaporates, carefully peel off the paper. The finished board is ready to solder. I used a wet sponge to remove any paper fibers. All the components were mounted and soldered. The LED requires an 11mm spacer. The 5-watt resistor is also spaced off the board with 12mm insulation sleeves. The finished circuit board is ready to install. The power cord and heating element will be soldered to the PC board. The live conductor is soldered first. The neutral conductor is soldered next. The red lead of the heating element is soldered to the pad marked J2-1. The black lead of the heating element is soldered to the pad marked J2-2. The following slides show how to reassemble the steamer. Please refer to the previous video for more details. After the silicone adhesive has cured for 7 days, the unit is heat tested with plain distilled water. The countdown timer is activated and power is sent to the steamers. The power button is pressed on each unit. The unit on the right has the original factory circuit board. The unit on the left has the repair circuit. Both units power up normally. I hope you liked the video. Thank you for watching.